Number 7 says to evaluate each function and write the answers as ordered pairs. So A says to evaluate h with x value 7. So what I'm going to do here before I get started is I'm just going to color code. This is f of x, this is g of x, and this is h of x. So I'm just going to kind of color code which function I'm going to use for each one. So this is h of x. So I'm going to use the last function. Are there any other h's? Here's f of x. Here's another h of x. I'm going to find x if h of x is 9. That one's a little different. And are there any g of x's here? Yes, I'm going to use g of x for c, and I'm going to use g of x for f. And finally, the f of x, I'm going to use it for b, and I'm going to use it for d. Okay, so let's start with number 7. Number 7 is evaluating h, function h for the input x value 7. So h of 7 is going to equal, and I'm just going to put a 7 where the x was in function h. 7 take away 7 over 3. So 7 take away 7, you got to use the order of operations here. And the numerator is an implied grouping symbol, so we're going to do that before we divide. 7 take away 7 is 0, divided by 3, so that's equal to 0. So the ordered pair, it says to write the answer as an ordered pair. It's going to be the ordered pair 7, 0. When x is 7, h of x is equal to 0. Okay, so the next one is f of 6. We're going to evaluate function f for a 6. So I'm going to rewrite the function, putting a 6 in parentheses where the x was, minus 12. So using the order of operations, I do the multiplication before the subtraction. That's 5 times 6, which is 30, minus 12. And 30 minus 12 is going to be 18. So writing my answer as an ordered pair, the input was 6, the output is 18. In other words, x is 6, f of x is 18. Okay, letter C, g of 10. So now we're going to evaluate this middle function. G of 10 equals 1 half, and where the x is, we're going to put a 10. 1 half times 10 minus 4. So again, doing multiplication first, we're going to do 1 half times 10. Now I can't multiply a whole number by a fraction unless I make the whole number a fraction. And when I do so, you multiply numerator by numerator, 1 times 10, which is 10, and denominator times denominator, which is 2. And so then I'm going to divide this fraction first. 10 divided by 2 is 5, so this turns into 5 minus 4, which is equal to 1. So g of 10 is equal to 1. So the ordered pair would be 10, 1. So when x is 10, g of 10 is 1. Okay, so now going on to D, we're going to find f of x. We're going to find x if f of x is equal to 3. So this is a little bit different. Now we're going to substitute where f of x is here. Let me just write the function out. F of x is equal to 5x minus 12. So because f of x is equal to 3, f of x is the same as 3. So in place of the f of x, I'm going to put a 3. And that's equal to 5x minus 12. So now we're solving this. And now we're using the order of operations backwards. We're going to isolate the variable x. So the first thing I'm going to do is add 12 to both sides. Bring down my equal sign. And 3 plus 12 is 15. That's equal to positive 5x. I'm going to divide by 5 by both sides because that's what's being multiplied by x. Bring down my equal sign. If these one each other, I'm just left with x on the right hand side. On the left hand side, I'm left with 3. 15 divided by 5 is 3. I'm just going to plug that back in just to check. 5 times 3 is 15. Take away 12 is equal to 3. So that is good. So the ordered pair for D would be 3, um, 3 actually. When f of x is 3, x is 3. Okay, so for e, we're going to go ahead and do e in blue. Bring it down over here. Um, now h of x is 9, so I'm going to write the function h of x right here. H of x is equal to x minus 7 over 3. And since h of x is 9, I'm going to substitute a 9 for h of x. So 9 is equal to x minus 7 over 3. So now the first thing I'm going to do in this equation is I'm going to undo the division by multiplying by 3. And I'm going to do the one side, I do the other. So these two 3's cancel out. I'm left with 27 is equal to x minus 7. Now to further isolate the x, I'm going to add 7 to both sides. And so I have 34 is equal to x. And I'm just going to go ahead and just drop it in here to check. 34 take away 7 is 27. 27 divided by 3 is 9. And that's what we have there. So our ordered pair for E is 34, 9. And we're going to bring down F because we're running out of room here. So F says find x if g of x is 12. So I'm going to write out g of x. G of x is 1 half x minus 4. So in place of the g of x, we're putting a 12. 12 is equal to 1 half x, take away 4. I'm going to add 4 to both sides in order to find this x. 12 plus 4 is 16. And these cancel out. Bring down the equal sign. I'm left with 1 half of x is equal to 16. So I could divide both sides by half, but I prefer to multiply by the reciprocal of this coefficient right here, by the multiplicative inverse. So I'm going to multiply by this side by 2 over 1, multiply this side by 2, which is the same as 2 over 1. Whatever I do to one side, I do the other. So on the left-hand side, I have 32. And if I multiply 1 half by 2 over 1, everything ones each other out, and I'm just left with 1x or x. So x equals 32. So the ordered pair for f would be 32, and the x value they gave us was 12. Okay, taking a look at number 8, what's the domain of the function shown? So you have two things. You have domain and you have range. Now, one of them is the collection of all the inputs, the other one's a collection of all the outputs. In other words, one of them's a collection of x's, the other is a collection of y's. So just as in an ordered pair, x comes before y, and same thing as in the alphabet, D comes before R. So the domain is actually going to go with all your x values, and your range is going to go with all your y values. So because the domain goes with all the x values, I'm just going to kind of look at, and because the x values go left to right, I'm just going to kind of draw a line like this at the end of this function right there to right there, to see which x values this graph contains. And it has all the x values from -4 to 2. Now this is an example of a continuous graph. This is continuous data. So when you have continuous data, it's impossible to list all of the values because between -4 and -3, there's an infinite number of numbers. So we're going to write this as we're going to write the domain as a interval. And so it's all the real numbers greater than or equal to -4, right? Because it starts at -4 and it goes to 2. So it's less than or equal to 2. Now, the reason I use the greater than or equal to and less than or equal to is because at the end of this, notice that the bubbles are filled in right here. Now, the range of the function, as we mentioned, are all the y values. So I'm going to get these I'm going to get these lines and I'm going to turn them horizontally. And it's going to go from right there. And this one's not perfectly horizontal to right there. So from the bottom to the top. So this goes from y equals 1 to it looks like y equals 5. So my range, and again, because it's continuous, I'm not going to list them as we listed the domain and range here because this is just a bunch of points. There's a countable number of domain and range there, so we can list it like that, but there's an infinite number of domain and range between 1 and 5. There's an infinite number of numbers, so we're going to say all real numbers greater than 1 and less than or equal to 5. I'm sorry, greater or equal to 1 less than 5. Now, let's get these out of the way because the next question says, what's the rate of change from x equals -4 to x equals -1? So a synonym for the rate of change is slope. And one way of finding the slope is to use a slope formula. M equals y sub 2 minus y sub 1 over x sub 2, take away x sub 1. And so this coordinate right here is a coordinate -4, 1. This coordinate over here is a coordinate 2, 5. So I'm just going to go ahead and call this the first point. So this is my x sub 1 and my y sub 1. This is my second point. This is my x sub 2 and my y sub 2. And I'm going to plug these into the slope formula. So y sub 2, which is 5, minus y sub 1, which is 1, divided by x sub 2, which is 2, minus x sub 1, which is -4. So 5 take away 1 is 4. 2 take away -4. When you're taking away a negative, it's like adding a positive. So 2 plus 4 is 6. So this is 4/6. And simplified, it's 2/3. So the rate of change between these 2 points, and I just realized something, this is not x equals -1. X equals -1 is right here. And so we're going to find the slope the other way, the rate of change the other way, which is finding the rise and a run. So it rises 2 and it runs 3. So either way, the rate of change is still 2/3 between x equals -4 and x equals -1. And identify 2 points on the graph. So we went ahead, we did that already actually. Um, one of the points is going to be this point right here, -4, 1, and the other point is going to be 2, 5. Their answers could vary for part D.